Okay, yeah, I'm Harsha. I'm a professor in computer science at USC. Very happy to be presenting here. So what I'm going to be talking about today is how do you do quality assurance at scale when you're archiving lots of modern web pages which contain lots and lots of JavaScript. All right, so this is actually work largely done by my students, my PhD students Jingyuan and Huanchen, who ideally should be presenting this work. Unfortunately, with US visa complications, they cannot leave the country at this point. So I'm here. And also, unfortunately, I woke up this morning with the not so great news that the grant from IMLS supporting all of this work has been terminated. So after you hear this talk, if you have suggestions for where else we could get support, happy to hear that. So what's the context for this work? This probably, this audience doesn't need education about this, but archiving web pages largely has two separate pipelines, right? On the one hand, you need to record pages wherein you crawl them, you store WARC files which contain all the resources on the page. I've done a bunch of work previously on how to do browser-based crawling efficiently at scale and ensure you get high fidelity capture of the page resources. But after that, once you do capture these resources in WARC files, you need to feed them into something like Wayback Machine or PyWeb to accurately replay the page. So today's talk is mostly going to focus on this replay part of the pipeline, which is even if you do very good captures, why might you have errors in terms of replaying? So the core problem that happens in replay, especially on JavaScript-heavy web pages, is you need to rewrite the scripts on the page, both statically and dynamically, so that when a user loads this page, any resources on the page, be it images, other scripts, style sheets, which are dynamically fetched, are fetched from the archive and not from the original domain. Right, so this is a very simple example where, let's say you capture a snapshot of the CNN.com homepage. If you do correct rewriting, you're going to see all the images. If you don't, all this is missing. Right? Unfortunately, even with state-of-the-art replay tools, like particularly PyWeb, replayweb.page, and so on, this cannot be done today with perfect fidelity. Right? So this is, for example, example web page from the end of term collection. On the left, you see a live web page. Everything on this is perfectly been captured using a browser-based crawler. But when you replay, unfortunately, the carousel is missing, many of the images are missing, and so on. Why does this happen? Because when you replay the page, because of bugs in rewriting the scripts, you end up with runtime errors, which halts the execution of the scripts, and in turn, everything on the page doesn't load. So these problems are not just limited to visual problems. We also see lots of functional problems on web pages. For example, this is a page wherein if on the live web page, if you hover over the menu bar, it comes up with a drop-down which shows various other navigational links. Now on the archive page, again, everything is captured perfectly, but now you hover over this menu bar, there is no drop-down. And again, the same cause, there is a runtime error in executing the script, and the page doesn't fully load. Right? So just to kind of now set the stage for what we are exactly trying to do, on the one hand, we are trying to develop automated mechanisms rather than requiring manual inspection. How do we automatically detect when these fidelity violations occur? And particularly because of rewriting, not necessarily because even if you have the perfect capture, why might these problems occur? And secondly, not just detect that there's a problem, but do some diagnosis of the root cause so that we can give actionable feedback to the developers of PyWeb and such tools so that they can actually go in and fix the corresponding issues. So we're actively working with the web recorder team to communicate back all our findings to help them fix this in the future. So let's see how does this work today, right? Today, if you archive one web page, yeah, sure, you can load it again, compare the two, make sure everything is great. But if you have crawled tons of web pages, you probably have to use some automated quality assurance mechanisms. For example, this is how things work in browser tricks, wherein you've crawled a page, that is a live web page on the left, it loads the archived copy on the right, and then it comes up with a bunch of statistics comparing the two, right? And again, this is by no means meant to nitpick on browser tricks. We love those guys and we were working with them, but these are standard metrics that anybody might use to compare the archived page and the replayed page. So let me talk about some of the limitations of this, right? So, for example, comparing screenshots is a very common way to do this, but unfortunately, this leads to lots of false positives on modern web pages, right? So on the left, for example, is the CNN homepage. There's an autoplay video. So even if on the same page, if you capture screenshots multiple times, these are going to differ. Or on the right, this is like MIT's homepage. It uses JavaScript to do some typewriter effect, wherein it keeps showing different suggested search queries. Again, different screenshots are going to differ, but there is no actual fidelity problem. You might also consider looking at the browser's console to see if it reports any errors that might perhaps correspond to a problem. But again, this is not perfect. There are lots and lots of cases where the browser reports errors, but these errors have nothing to do with the visual or functional fidelity of the page. Right? These errors occur in unused scripts, or they occur in analytic scripts, which are totally fine. Right? And the flip side of this also is there are many cases where fidelity is violated and there are no errors whatsoever. So this is a simple example wherein we archive Google's homepage using web recorder. So on the live web page, if you click on this app icon, it actually comes up with a drop down. But when we replay, it just fails to load. Right? And if you look at the browser console, there are no errors whatsoever. So these are basically cases where, because of the errors in rewriting the script executes incorrectly but doesn't result in any externally visible errors. Right? So far I've told you what the problem is, and I'm roughly at half the time, so that's perfect. So now let's talk about the solution. So this is our proposed solution, which we have been working on, called FIDEX, short for Fidelity Violation Exposure. So this is a high-level overview of how it works. So today, normal QA systems would work as follows, right? You would archive a page, store the work files, you would probably load the page again, compare the two, and see if there's any problems. So compared to the standard QA pipeline, what we are doing is we are adding additional instrumentation into the browser, which both is executed when crawling the page as well as when replaying. Right? And this additional instrumentation leads to some logs, which we later analyze offline to detect if there has been a problem in fidelity. And then we can also use these logs to kind of pinpoint exactly what was the problematic rewrite of JavaScript so that the developers have actionable feedback. So in this talk, given I have only so much time, I'm going to focus mostly on detection, and that too only on a certain aspect, which is what is the right representation of a web page final output to compare. So for this, I need to get a bit technical. I'm still going to keep it pretty high level. So we need to have an understanding of what exactly does a web browser do when loading a web page, right? So there are multiple steps involved. The first thing a browser does is it goes and fetches all the resources on the page, HTML, CSS, JavaScript. It builds two data structures, the DOM tree and the CSS OM tree. The JavaScript can write to both of these as the page loads. Then by combining all of this, the browser produces a data structure called the layout tree, which basically captures what are all the visible elements, what is their position on the page, what are the dimensions. And then using all of this, the browser then actually renders the pixels on the page. So if you think of screenshot, really it is only capturing this final outcome, which is what are the values of all the pixels on the page. And this is continually changing. If there's a dynamic page, the pixels are constantly being altered. So our key insight is you shouldn't be looking at just the rendered pixels, but rather this intermediate state as to what exactly is the layout tree the browser computes, and what are the writes the JavaScripts perform on this layout tree. So if you go back to the examples I sent earlier, so in the CNN example, yeah, the video keeps changing the pixels on the page, but actually if you look at the layout tree, it is unchanged throughout. So if you compare if the layout tree when you archive and the layout tree when you replay, it is exactly identical. You tell there is no problem with fidelity. This doesn't work in the other case because indeed the layout tree is changing as the JavaScript modifies the page. But in this case, we can actually identify which JavaScript code is producing this typewriting effect. Right? There are some details in how to do that. But as long as we can capture all these writes, we can compare the writes executed when archiving the page and those executed when replaying the page. If these writes are identical, then again we know there's no problem. So right, so in FidX we're really combining both the comparison of layout tree and JavaScript writes to do this. Now I don't have time to get into all this the pinpointing stuff. Happy to describe more about it, but at a very high level, what we're really doing is on the one hand discovering errors that are not reported by the browser. Right, it's kind of silent semantic errors of in executing the page, and then identifying which of these errors actually have impact on the page fidelity, so that the developers can go fix that. So let me give you a high-level overview of some of our results. So we have done so far evaluation on a corpus of about 80,000 web pages, which are sampled from the top 1 million websites. We also applied this technique on a bunch of web pages, both from the end-of-term collection as well as the Carta collaborative art archive collections. We compare this with some of the techniques used by browser tricks as a existing baseline. And we also look at if the loading the archived copy reports any extra errors not seen when crawling the page, that might perhaps also be indicative of problems. So here is the results from on the 80,000 corpus. We found with FidX, we find roughly 15% of pages are such that the archived copy, when replayed, doesn't precisely match the crawled copy. Of course, this rate is much higher in the other techniques, and this boils down to the fact that using screenshots and comparing HTML text and so on has lots and lots of false positives, right? For the reasons I mentioned earlier. And on the flip side, of course, compared to screenshots, we do have some false negatives. And it's worthwhile to note here that if you had a very naive classifier which declared everything as there's no problem whatsoever, even that would get a 15% false negative rate. So 10% is pretty bad if you rely on comparing the HTML text. So I have 1.5 minutes, so let me use this time to quickly show you some examples, right? So like on the end of term collection, we see examples like this where there are elements on the page which were captured while crawling but are missing during replay. As I also hinted at the beginning of the talk, there are also examples wherein there are some menu bars which work in the original page but don't work while replaying. The flip side of this also is we see tons and tons of examples where if you use the screenshot, it would say, yeah, fidelity is a problem, but our techniques can correctly observe that there is no problem whatsoever in replaying these pages. Same things happen in the Carta collection too. There are many pages where the archived copy, despite high fidelity crawl, the replay doesn't work. Here is an example where the button to toggle between dark mode and normal mode is broken because of JavaScript errors. And here too, I mean, this is even more so. There are lots of art websites which have so much dynamism that if you compare screenshots, you're going to have tons and tons of false positives. So overall, high-level bit here is JavaScript is so complex, it's very hard to rewrite it correctly. So there are going to be bugs, and there do exist bugs, and this results in poor fidelity replay. Implications are in terms of detecting these problems. You cannot just rely on screenshots on modern web pages. So our suggestion is to, our system is meant to use comparison of layout tree and the JavaScript writes. And on the other hand, for diagnosis, you can't always just rely on the errors reported by the browser. You need to go deeper than that. And we also have techniques to confirm which of these errors are actually worth investigating. That's it. Happy to take any questions.